What's going on, everyone? Welcome back. Patrick here, and moving on to the next question. We are given this triangle ABC where A is -6, -5, B is 8 and 2, and then C is 3 and 9. And given all that, number one, we have to find the midpoints M and N, which are going to be the midpoints of line AB and line AC, respectively. And then once we have those midpoints, number two, we got to verify that MN is going to be half the length of BC. And then number three, we have to verify that MN is parallel to BC, that those two lines are going to be parallel. So this is a popular type of question. And let me just show you in a diagram first what is happening. So we got this triangle. I'll let this be A, I'll let this be B, and then I'll let that be C. So first thing we're going to do is we're going to find the midpoints of AB and AC. So the midpoint of AB, it's going to be like over here, and we're calling that point M. And then the midpoint of AC is going to be over here, and we're calling that N. Now, just in general, for any triangle, this is always going to hold. So no matter what coordinates you're given, once you have these midpoints here of these two sides, basically this length is going to always be half of this length, and these two lines are going to be parallel. Okay, so I didn't graph these points on a Cartesian plane just because there's going to be a lot of lines and stuff. I want you to see clearly what is happening, and in this case it's not as necessary to get the exact location of the points. I'm actually just going to keep this triangle and just put the points over here. But if you want, you can graph it. Right? This triangle might be like flipped over and transformed in a certain way. But I just want to keep it like this just so you could clearly see what is happening without too much confusion. And again, no matter what triangle you're working with, no matter what points you're working with, this is always going to hold. So basically, this length is going to be half of BC. So the first property is that half of BC is going to equal MN. Or another way to write it is BC, this length, is equal to 2 times the length of MN. Right? Both of those statements are the exact same thing. We just took this half and brought it to the other side, so multiplied it by 2 to get that over there. So that's the first property, and then the second property is that the line MN is going to be parallel. That's usually the symbol for parallel with line BC. Right? So we're going to confirm or verify those properties with these specific points that we are working with. So let's start off with finding the midpoint M. So that's going to be the first step, is finding those two midpoints. So M, first off, midpoint in general, how do we find that? Well, if we have 2 points, x1, y1, x2, y2, we would add the x values divided by 2, add the y values divided by 2. So we're finding the midpoints between A, B. So I'm going to let this be x1, y1. I'll let this be x2, y2. So point M is going to be the two x values added together. So -6 plus 8. When you're dealing with negatives, you could even put brackets around these just to not get confused, because if you did it the other way, then it would just be 8 plus -6, like that. And then these two would turn into a negative, the plus and minus, and then you would end up with +2. Same thing here, -6 plus 8 gives us +2. And that's going to be divided by 2, and then we'll have y1, which in this case is -5, plus y2, which is +2, and we're going to be dividing that by 2 like that. So we would end up over here with 2 over 2, Over here, we'd end up with negative 3 over 2, and then 2 over 2, that simplifies to 1. Negative 3 over 2, that's negative 1.5. I'm going to keep it as a fraction. It's tougher to deal with fractions versus decimals, so just in case you have to deal with fractions, that's what I'm going to show in this video. So this point here, m, ends up being 1 and negative 3 over 2, negative 1.5. Okay, now what about point n? So point n is going to be the midpoint between AC. So we already let A be x1, y1, so I'll let C be x2, y2. So we would have negative 6 plus the x value 2, x2, the x value of 3, which is x2. Give me a sec here, yeah. And then we're going to divide that by 2. And then we'll have y1, which is negative 5, plus y2, which is 9. And we're going to divide that by 2. So over here, negative 6 plus 3 gives us negative 3. That's going to be over 2. Negative 5 plus 9 gives us positive 4. That's going to be divided by 2. Just be careful with your algebra over here, especially if you're dealing with fractions. So that's going to be the midpoint n. Negative 3 over 2 and 2. So that's going to be over here, like that. Okay, so we have the midpoints, and now we can move on to number 2, where we have to verify that this length mn is going to be half of the length of BC. So length formula, just as a review in general, it's the square root of x2 minus x1, that's going to be squared, y2 minus y1. That's going to be squared like that. So for this, I'm going to let this be x1, y1. I'm going to let this be x2, y2. So this is going to be kind of hectic as a heads up because we're going to be working with fractions here. But that's okay. So x2, negative 3 over 2, minus, and by the way, you can if you're dealing with negatives and stuff, you can, as we did with the midpoint formula, you can put the x2 and the x1 in brackets like that, just so you're not getting confused with all the different brackets that are going to come up here. So x2, this negative 3 over 2, we could put in its own bracket like that. Then we're going to be subtracting x1, which is positive 1 like that. Then you can maybe put square brackets. Just so you know that we got to work with these terms first before squaring that square bracket. Okay, and then same thing over here, the y2 we could put in brackets, so we'll have 2 minus y1, which is negative 3 over 2, and then we're going to be squaring that right there. Right, and if you get something like this with fractions, I actually recommend just working with it on the side versus within here, because it could start getting messy. So that's what I'm going to do. I'm going to work with the negative 3 over 2 minus 1 first. Now 1 is over 1. To add or subtract two fractions, we need a common denominator between 2 and 1. That's going to be 2. That's the lowest common denominator. Multiply this by 2, multiply this by 2. We'd end up with negative 3 over 2 minus 2 over 2, which would give us negative 5 over 2. So this, within this square bracket, ends up equaling negative 5 over 2. So this is going to be negative 5 over 2 right here. And we're going to be squaring that. Plus, we'll have 2 minus negative 3 over 2, which is 2 plus 3 over 2. The 2 is over 1. What's the lowest common denominator between 1 and 2? It's 2, so 2, 2. So we'd have 4 over 2 plus 3 over 2, which gives us 7 over 2, right? So this here ends up being 7 over 2 within that square bracket. And then we're going to be squaring that like that. So from here, what you want to do is whenever you're taking a fraction to an exponent, well, you could take the numerator to that exponent, you could take the denominator to that exponent. So what we can do here, the -5, we can, let's actually do it on the side. So -5 over 2 squared. So we could take the -5 to the power of 2, and then we could take the 2 to the power of 2. And so this would end up giving us 25 over 4, like that. Okay, you could just maybe work with decimals as well, but just in case your teacher wants all of the work in fractions, which is a lot tougher to do, I'm going to show you how to do all that with all these rules. So this here would end up being 25 over 4 plus 7 over 2, which is like 7 squared over 2 squared, which gives us 49 over 4. So this is going to end up being 49 over 4 like that. So here, what we can do is, let me actually erase this. We would end up with the square root of, notice we already have a common denominator, so we could add these 25 plus 49 would give us what, 74? And that's going to be over 4, like that. And then 74 over 4, that actually simplifies into what, 37 over 2. So I'll have the square root of 37 over 2 like that. And I'm going to keep it like this in exact values. You can get the decimals for this if you want. And if you do that in your calculator, just make sure you do the 37 over 2 first, which would be 18.5. Square root of 18.5 is going to give you approximately 4.301 if we round it to 3 decimal places. Okay, so that is the length of MN. So either the square root of 37 over 2 or in decimals 4.301. Okay, I'm going to keep this exact value in case your teacher wants you to work with exact values. It's a lot easier to just work with decimals, but I'm going to show you that once we get the length of BC, which is going to be an exact value as well, how we can show that this is going to be half of the length of BC with exact values. Again, we'll get the decimal as well of BC, and then you can just tell from there easily that BC is going to be twice the length of MN, but with exact values, it's going to be a little tougher. So I'm going to show you both ways. Now, with BC, we got to find the length of that. So we let this be x2, y2. I'm going to let this be x1, y1. So we would have the square root, let's put the square bracket, 8 minus 3, that's going to be squared, right? x2 minus x1 plus y2, 2 minus y1, which is 9. And we're going to be squaring that. So this would end up being, what's this going to be here? This is going to be 5 to, let's just actually write it out, 5 to the power 2 plus -7 to the power 2, which would be 25 plus 49, which would give us 74, like that. Okay, so this is the length of BC as an exact value. And if you take the square root of 74, if you want to get the decimal, you'd end up getting 8.602 if you round to 3 decimal places. So that's the length of BC, which as an exact value is the square root of 74. And then as a decimal, it's 8.602. So if your teacher allows you to just work with decimals, well, then at this point you're done, number 2, because notice that this is double that, right? If we take this, multiply it by 2, we would end up with that. Or if we take this, multiply it by a half, we'd end up with that. So with decimals, we showed it right there. But what if, let's say, for example, you're not allowed to use a calculator in your specific class, and you have to show with exact values that this is going to be half of that? Well, then it's a little bit more tricky. What you're going to have to do is remember that to multiply two decimal values, or two radical values, rather, they both have to be under the square root in order to multiply them. So this would end up being square root of AB, like that. So what we want to do is we want to show that 2 times this length. So let's write that out. We want to show 2 times the square root, let's put this in brackets, times the square root of 37 over 2 is equal to the square root of 74. Right? The question is, how do we go from this? What kind of algebra do we do to get to this over here? And I've done this in a previous video, but the way you do it is, remember, to multiply 2 of these, they both have to be under the square root. So notice we have 37 over 2 under a square root, but this 2 is by itself. Okay, so a square root b does not equal root ab. Why? Because the a is not under a square root. Okay, in order to be able to do this, the a has to be under a square root as well, and then it's going to equal. So what we have to do is, instead of having a 2 here, we have to have the square root of something. So notice that 2, well, if we square that, it's 4, so we know that this is the same as the square root of 4. And then we got the square root of 37 over 2. Okay, this and this are the exact same thing. We just took the 2, changed it to be a square root of 4, and now because they're both under a square root, we can multiply these two values. So this is going to be the same as the square root of 4 times 37 over 2, like that. And then from here, you can tell that, notice 2 goes into 4 twice, right? 4 over 2 simplifies to 2 over 1, then 2 times 37 gives us 74. And so we showed that this multiplied by 2 equals the square root of 74. That's how you show the work using exact values. If you didn't want to do this over here, so you'd have like 4 times 37 over 2, just put the 4 over 1, and then you'd have 4 times 37, which would give us 148. 1 times 2, which is 2. 148 over 2 gives us 74. So whichever way you do it, 4 times 37 over 2 is 74. And it's all under a square root over here, right? This was all under a square root the whole time. So we showed that 2 times this length is equal to BC. And if you remember what I wrote out before, one of the statements was 2mn has to equal BC. Well, we just proved that right here, given those two lengths. Okay, so again, with decimals, it's a lot easier. You just take this multiplied by 2 to get that. But if you're showing it with exact values, if you can't use a calculator, you got to take the 2, change it to a square root of 4, and then you can multiply the square roots, and you should get that value, which we did. Okay, so whichever way you do it, we are done with number 2. And then finally, number 3, what we got to do is we got to show that this line is parallel to this line. So we just have to find the slope now. Just as a review, what's the slope formula? Rise over run, which is y2 minus y1 over x2 minus x1. So we got to find that for MN, BC. Both of those slopes should equal. So from here, we actually have everything labeled already. So notice that if we're going to find the slope of MN, we got x2, y2, x1, y1. And so again, if you're working with like negatives and stuff, you could just put these in brackets like that, just so you could see it a little better. So that's what I'm going to do. Actually, I didn't even have to put this big bracket here. So we would end up with y2, which is 2, minus y1, which is negative 3 over 2. And then that's going to be over x2, which is negative 3 over 2, minus x1, which is 1, like that. Now from here, if you have fractions within this big fraction, I would work with the numerator and denominator separately. So this 2 minus negative 3 over 2, that's the same as 2 plus 3 over 2, right? This negative negative turned into a positive, so this 2 is like over 1. Multiply this by 2, multiply that by 2 to get a common denominator of 2. So this would be 4 over 2 plus 3 over 2, which would give us 7 over 2. Right? So a little tedious, lots of algebra, but we got to go through it either way. So this numerator ends up being 7 over 2, then we'll have negative 3 over 2 minus 1, which is like over 1. Common denominator is 2, multiply that by 2, multiply that by 2. So negative 3 over 2 minus 2 over 2, which gives us negative 5 over 2. Right? So this denominator simplifies to negative 5 over 2, like that. So now we have one fraction divided by another fraction. So let's actually rewrite that as 7 over 2 divided by negative 5 over 2. Personally, I like to take something like this, rewrite it like that. It's just easier to see. And now if we're dividing by a fraction, that's the same thing as multiplying it by the reciprocal of that second fraction. And then notice these 2's would cancel out, and so you'd end up with 7 over negative 5, or negative 7 over 5. If you didn't cancel out the 2's, it would be 14 over negative 10, which is like negative 14 over 10. And then simplifying that fraction, we could divide this by 2, divide that by 2, which would give us negative 7 over 5. Okay, so whichever way you do it, the slope of MN is equal to negative 7 over 5. So I'm going to write that over here. And then hopefully we end up getting the same slope for BC. And if it's the same slope, then we prove that both of those lines are parallel. So the slope of BC we already have x2, y2, x1, y1 labeled. Doesn't matter which order, still get the same slope. So we'll have y2, which is 2, minus y1, which is 9, over x2, 8, minus x1, which is 3. Just be careful with the slope formula. The x2, y2 should always be, the y2 should always be on top of the x2, the y1 should always be on top of the x1. Okay, so don't do y2 minus y1 over x1 minus x2. These should always be in line. And then it doesn't matter which coordinates you label as x1, y1, x2, y2. And then from here, this is nice. Actually, we don't have to deal with any fractions. It actually ends up just equaling 2 minus 9 is negative 7. 8 minus 3 ends up being 5. So that's the slope of BC. So the slope of BC we showed is equal to the slope of mn. And so we are done number 3. We verified that mn is parallel to